I'm Stevens. Welcome for today's lesson. Today's lesson is linear motion. We are going to take a question on linear motion, and the question is: a stone is allowed to fall freely from the top of a tower 60 meters high. At exactly the same moment, a second stone is thrown vertically upwards with a velocity of 20 meters per second from the ground. Find, Roman 1, the time taken for the two stones to pass each other, 3 marks. Roman 2, the height at which the two stones will pass each other. So viewers, the question we are having here is about some two stones. One stone is allowed to fall freely from a tower, and the height from which it is falling from the point of release to the ground is 60 meters, and the other stone is thrown, that is projected vertically from a certain point or from the ground, which is 20 at a velocity of 20 meters per second. Then the question is, the first question, we want to know the time taken for these stones to pass each other. Therefore, I'm going to represent this one in a diagram form before we now execute. So, this is my stone that is released from a height which is 60 meters from the ground. So this is the point of release. This is a free fall. This is a free fall. Then at exactly the same time, another stone is released or is vertically projected upward with an initial velocity of 20 meters per second. Okay, now I want us to assume, or we are going to let a point at which this stone will meet to be x from the ground. So I'll say let the two stones meet x meters from the ground. So that is my first approach. So I'm going to assume that these stones are going to meet at a point like this. This is the meeting point. And from the meeting point to the ground, we have x meters. So the remaining distance here from the meeting point upwards, it is 60 minus x. So by the time the two stones are meeting, the stone that was released from the top of a tower shall have traveled a distance of 60 minus x, and by the time the two stones are also meeting, the one that was vertically projected shall have traveled x meters from the ground. Therefore, we are going to pick the two equations, one equation from free fall and the other equation from vertical projection. For a free fall, we are going to pick the second equation, s is equals to ut plus a half gt squared. So that is the equation for a free fall that we're going to use for this one. For the other equation for the vertical projection, the second equation reads s is equals to ut minus a half gt squared. So here it is a minus, here is a plus. The reason why we have a minus here is because of g. It is in the opposite direction of the normal g. So this stone is going to undergo deceleration due to the force of gravity or due to gravity. And for the first equation here, where we have the free fall, we have a plus because this stone undergoes acceleration due to gravity g. So we are going to start with the free fall. So this one becomes our s. So we are going to assume that by the time of meeting, the displacement for the first stone is going to be 60 minus x. So we say 60 minus x equals to the u, that is the initial velocity of this stone that was falling freely, is 0 because it was held, and because it was held, the initial velocity goes to 0, so everything here goes to 0. So u, which is 0 times t, is 0. So that one goes to 0. Then I have a half times g, which is 10, times t squared. You don't know t squared. So 60 minus x is equals to when we multiply half by 10, we get 5t squared. Of course, times t squared. So this one will be like my equation 1. So I'm going to substitute the equation for, I'm going to substitute for the second equation, this equation here, using the vertical projection as a stone that is vertically projected. So this distance s is the displacement I mean, so it is taking the value x, so x is equals to, because I'm assuming that by the time the stones were meeting, the one that was vertically projected shall have traveled a distance equivalent to x meters. So x is equals to ut. Our u here is the initial velocity, which is 20. So I'll have 20 t, then minus a half times 10, the g takes 10, and then times t squared. So at that particular point, we have x is equals to 20t minus 5t squared. When you multiply 10 by half, you get 5. Then 5 times t squared is 5t squared. This one becomes equation 2. So right now I have equation 1 and equation 2. And these two equations are talking about displacement. The total displacement should be 60. So if I take this displacement by the stone that is vertically projected, the displacement that it has by the time they are meeting, plus the displacement this one has underwent by the time they are meeting, if I add the two, I should get 60. So I simply add these two equations and I equate them to 60. Or rather, I can equate these two, I can add these two equations. I can say that add equation 1 and 2. Also, when you are adding, we add both sides. So I'll take 60 minus x, I add it to x, so I'll get 60 minus x plus x equal to 5t squared plus 20t minus 5t squared. So mathematically this side I'll have 60 because this is 60 minus x plus x. It is simply 60 equal to, you can see it has come to 60 because if I add the displacement of the two stones, from the one from the ground and the one from the tower, by the time they are meeting, their displacement, the sum of their displacement must be 60. As you can see, this is the displacement for the stones, the stone that was vertically projected, and this one was the one that was undergoing free fall. So I'll have 5t squared minus 5t squared. This one will vanish because this is positive 5t squared, and negative 5t squared it goes. So I'll have 20t and divide by 20 and divide 20 both sides. So I get that t is 3 seconds. You can choose to write in full, but I should not write sec. It is not allowed. So t is equals to 3 seconds. So the time taken for the two stones to pass each other is 3 seconds. That is the time taken for them to pass each other. Then the next question is the height at which the two stones will pass each other. The height at which the two stones will pass each other. After calculating this height, I need to tell the examiner, is it from the top of the tower or from the ground? So at that particular point, I will substitute because I need the height, which is the same as the displacement in this case. So I'm going to substitute, and during substitution, I can substitute either in equation 1. So if I substitute in equation 1, this is my equation 1. This is my equation 1. I'll say 60 minus x equals to 5t squared. So what is my t? My t is 3. So I put 3 here and I say 60 minus x is equals to 5 into 3 squared. So 3 squared, this is the time squared. So 9. So 60 minus x is equals to 45 because 3 squared is 9, 9 times 5 is 45. Then I can move this 45 this other side and I take x the other side. So that I'll have 60 minus 45 is equal to x. Because when x crosses the other side it becomes positive. And therefore x is equals to 15 meters. So in short, from my assumption here that I said let the two stones meet x meters from the ground, and the question is the height at which the two stones will pass each other. So the stones will pass each other 15 meters from the ground. So the stones pass each other 15 meters from the ground. So thank you for watching. Remember to subscribe, hit the subscription button, share, comment and like. Thank you. Meet you in the next video.